Hi everyone, my name is Tomasz Danel and I'm a co-author of the paper Songs, Self-Organizing Neural Graphs, which I am going to walk you through today. The research was done at the Jagiellonian University by Łukasz Struski, Tomasz Danel, Marek Smieja, Jacek Tabor and Bartosz Zieliński. The motivation for this paper was to propose a new neural architecture that builds on the advantages of decision trees. Song is a decision graph that shares all the listed benefits of decision trees, but has more flexible structure, requires less memory, and improves generalization. In Song, the input is transformed by a representation neural network and passes through the graph from the root to the leaves. The decision which path to choose is based on the input data and two trainable transition matrices represented by two colors of the arrows in the figure. The model is fully differentiable, so it can be trained using backpropagation. In the training, some connections in the graph are strengthened and other ones are weakened. At the end, the converged song is a binary acyclic graph as shown on the right. Here we can see a simple example of the song forward pass. Matrices M0 and M1 are multiplied by the decision function sigma to create the final transition matrix Px. At the beginning, the whole weight is put into the root, which can be represented in the vector v, which shows the distribution over nodes. The first step is calculated by multiplying px and v, and now the weights move to two other nodes, v1 and v2. Finally, after another step, some of the weights are moved to the leaves L1 and L2, which correspond to the prediction classes. This table shows the results of song for different numbers of nodes indicated in the parentheses compared to soft decision trees. The smaller version of our model already beats SDT without distillation, and for 2 out of 3 datasets we win over SDT even though we do not use distillation. The graph at the bottom shows an exemplary graph structure for MNIST, and the graph on the right is another example showing the averaged images in the nodes. To sum up, we introduce self-organizing neural graphs based on Markov processes, learning graph structure and transitions in the end-to-end manner. The model is fully differentiable, so it can be combined with other deep learning models. We prove empirically and theoretically that songs during training converge to sparse binary acyclic graphs. Thank you for listening.